Hello everyone, this is Byte Relay, Postgres Hacking 101, and we continue to work with shared buffer. And yesterday we implemented a function, something like drop shared buffers, drop caches, which was called flush shared buffers. And we were observing statistics about buffers, which is divided into shared buffers and local buffers. Let's see a little more about it. The statistic, we can find it easily in buff manager by simply looking for ++. See, this is a PG buffer usage, where is we can find statistic for local blocks and shared blocks, reads, writes, hits, etc. But you can see that this is statically defined in instrument C field. How does it work in Postgres? Each backend is a fork of Postmaster, so each backend have its own PG buffer usage statistics. And when you don't have to pass this object all over through your code. It's just statically allocated for this specific backend. Let's try to see what's inside buffer usage. A lot of fields like shared statistics and local statistics, temporary statistics, etc. We want to split these shared statistics into different kinds of workload. But let's look what kind of objects can we have. If we see in relation, we can find object relation, which is made of structure relation data, and within it we have so-called RD relation. This is a tuple read from system catalog, and this tuple have so-called RD RelKind. RelKind can be relation, basically table, index, sequence, toast value, view, and many others. We can see that it's basically one ASCII II character. So let's just make a dictionary of instrumentation by character. Let's call it RelKind buffer usage, and there we will have these four fields, and we can avoid colon and share it. Okay, let's keep it shared and have it RelKind usage. So now we have a two huge dictionary from a character to 4 bytes, and let's see how they are used within buffer manager. Whenever we do something with the statistics, shared something, we have to do the same with our buffer kind dictionary too, but we don't have our kind here. Let's see what it's made of. Where is it? Where is it? PG. I think it's not defined anywhere. Yeah, because it's automatically generated from system catalog. Okay, we can find how it's used. Yeah, we access relation object and then RelKind. And what type? It is char. Okay, so now everywhere we access something let's just close everything, close all, and open buff manager again. So we need here relation kind, just a char RelKind. Char RelKind. RelKind. Read buffer without relation cache. In this case, we have to pass 0 because without relation cache we don't get actual structure of relation, so nothing to be in statistics. I think that's it. So now everywhere we do something with shared statistics, we have to copy it and add something like, how did we call it? Oh, we have that in an improper place again. Do not ever edit code in temporary installation. It's just pointless. Unfortunately, Visual Studio Code is doing it now and then and again and again. Okay, so now it should work. No, it doesn't. RelKind usage. RelKind. And other stats too. Let's see if we have other shared blocks hit here. We have to pass here RelKind too. No, it's from xlog. When we read something from xlog, I think we don't need these statistics. We can just avoid updating our shared blocks hit. And that's it. Flash buffer. Oh, there is lots of calls to flash buffer and we need to pass everywhere. Okay, let's just, for the sake of short video, avoid updating blocks written, just blocks read and blocks hit. Where do we have a hit? Read reason. Yes, we have all the updates. And now we want to write this output this information somewhere during explain. See, explain is here. Shared blocks hit, shared blocks read, shared blocks written. Let's add these two. Indexes. And here we can get this. RelKind index. And again. Okay, let's try it. Make install. Something didn't work well. I defined structure in the wrong way. That happens to me. Totally. Because I am writing many languages at different times, do not remember where do I have to have this semicolon or where I don't have to do it. Why it takes so much time? So now we have to stop Postgres if it's not stopped yet, and when it will get done. I have no idea why it takes so long. Maybe I was checking out something. The installation is almost complete. Yeah, restart. PSQL. Do we have? Yeah, shared buffers read. Shared buffers hit. And why it's not outputting? Why there is no output on indexes? Did I save the file? Probably so. Huh, that's the wrong place. You see, here is another. No, it's the right place. Yeah, this is the right place. Index hit, index read. Yeah, now it should work. By the way, probably compilation took so many time because we modified header files of very basic layer buffer manager, which is a kind of very low level subsystem. That's why almost all source code had to be recompiled. I do not observe anything new again. Because I made a mistake again. Yes. just shared hit and no shared hidden indexes. Let's make a short login statement when we are doing a proper shared blocks hit incrementation. If RelKind is index, yeah, just do elog warning. %, character RelKind. Oh, there was an incrementation for I saw it 3 times and 4 times. 4 times again. We see there was incrementation for index 3 times and for relation 4 times, but we don't observe the result. So looks like I need a time to debug, so I'll stop recording and look what's wrong. That's the choice. Okay, it took me a few minutes to understand what was going on. Actually, the function of accumulation buffer usage add was not accumulating as we would expect. Kind of we have to hack it for from 0 to 5. You see that the code I'm writing right now is not super clean, not even close to clean. As you may understand, this is for demonstration of minimum for to implement feature. Of course, real patches have to be much better. Doesn't work again. I don't know why. Okay, investigating further. Like it's actually very typical that when you implement something new, it doesn't work from the start, and once in a while it should happen with these videos too. Oh yeah. 5 minutes of debug more, and I found out that it's not enough to implement buffer accumulation. I also had to implement buffer subtraction, because without proper subtraction of buffer usages, the result was 0 again. But now I have finally fixed it, and it seems to work. I've just installed it, and now you see that we have shared hits 4, and out of these 4 hits we have 3 pages for index hits. I don't know how to show this better to user. There is just too much of instrumentation information now. If you have good ideas on how to arrange this information about what buffers were hit, what buffers were written, etc., Feel free to drop me a line in comments, and also I would very welcome suggestions for another patches, for simple patches that can be implemented online without very difficult preparation. Thanks for watching. Goodbye, see you in next videos on Byte Relate Postgres Hacking 101.